Each of these reactions, we're going to decide whether the products or the reactants are more common at equilibrium. So what that means at equilibrium is the rate of the forward reaction, which makes the products, equals the rate of the reverse reaction, which makes the reactants. That does not mean the concentrations are the same. Almost never means that, right? And we're given this Kc value. That is all we need, okay? Because that is what that tells us the relationship between Kc, equilibrium constant, tells us the relationship between the concentrations of the products over the concentrations of the reactants. If the equilibrium constant is much greater than 1, let's say 10 to the 3, like 1,000, more than 1,000, then the product, that's because the numerator is large and that would favor the products. So that's choice A. Products are favored. If you're trying to produce a lot of a certain type of product, you would pick a reaction with a high equilibrium constant. All right, so for B, the Kc value, it's a capital K by the way, is not super small and it's also not super big. Now, what's big and what's small? Because the products and reactants can get squared and cubed and all of that stuff, we need a certain degree of freedom to say what's being produced is large or small. All right, anyway, the point here is you're going to get both. There's going to be a good amount of both reactants and products. For a reaction where the mole ratios are all 1 to 1 to 1, you can say this is going to favor the, all right, let's do this here. Slightly different shade here. It's going to slightly, I don't know, slightly, you can say it favors, slightly favors products. The coefficients are all 1s. If they weren't all 1s, then it wouldn't be so easy, obvious to see that. Part C, this is the other scenario, our final scenario, where Kc is going to be really small. No, let me do this. The equilibrium constant is really small, much smaller than 1. 6 times 10 to the negative 28. Oh, that is like, you could just say this is no reaction, because you can put water under these conditions, whatever temperature it is and pressure it is, and because Kc is only dependent on the temperature, and none of this is going to be made virtually, because that's a very, very, very small number. All right, so this is going to greatly favor the reactants. There's going to be virtually no products being formed under these conditions, given that equilibrium constant. Reactants heavily favored. Or you can say this is an unfavorable reaction. You don't want to pick reactions with Kc values that are really small if you're trying to make a certain product.